Hello.
Hello. Yes. Am I audible? Yes, sir. Mr. Kartik Sahoo is from IIT Mandi, is a fantastic research scholar. He has taught us in MSc. Yes. Yes. Thank you. Hello.
Yes, sir. You are audible.
Hello. Yes, sir.
Kim sir, am I audible? Okay. Let me share my screen. Is my screen visible to everyone?
Yes, sir. Your screen is visible.
Is it now visible?
Ah, yes. Yes, sir. It is visible.
Okay. Evening, everyone. So, this is Kartik sir, and I am going to talk about ensemble of machine learning and self-promoting techniques for financial price forecasting problem.
Uh,
So, yeah,
Kartik sir, your mic is its a voice is lagging behind. It is not audible clearly.
is it audible now?
Sir, again.
Hello, is it
Ha,
audible now?
yes, sir. Yes, sir. You are audible.
Okay, okay. But I'm going to talk about ensemble of machine learning and self-promoting techniques for financial price forecasting program. So basically, in this talk, we have three modules. First, I am talking about learning predictive learning program. Then I will talk about sub-community technique. Then finally, we'll talk about what is financial literacy program and how we can use the machine learning and some community techniques together to finance. This is the outline of this presentation. So that's what I have told you. Like first we talk about predictive learning problem, then sub-community techniques, some sub-community techniques, then we'll talk about financial price forecasting program and some results. And so let's start. So basically, a predictive learning problem can be seen as a where we have one environment where we get our input vector x and our we have x and our desired response y that we want to predict using some learning system. Okay, so the structure will be an iterative process where the error signal actually help the learning system to get the response ideas that is more nearer to our response desired response y. Okay, so the critical learning problem can be categorized into two. That is one is classification problem and one is regression problem. So you can find this type of references uh, in between slides. Okay. So, so as you know, many of us I guess know that classification problem actually mean to uh, where the input set should be classified to one of the sets 1 to m if there is m classes. Like in first there is example we can see this is binary class and this is a multi-class problem where we have three classes. Okay, so basically classification problem in classification problem, we desire to find out and function of a that will give us the class of the input set, like which class it belongs. So for a binary class, I'm basically using support vector machine, one of the machine learning technique to solve classification problem because of its size and mentionability and it's static instead of neural network here. Okay, so in classification problem, we can divide if there is binary class, we can divide this. We can find one decision function, which is the line uh, that will divide these two classes, and similarly, different type of um, decision functions can be formed. Now, but what support function do? It actually desired to find one optimal decision plane out of these planes. Hello, am I audible? Yes. No, there is some noise. Okay. There is some noise due to network bandwidth. Uh, my internet is okay here, so I guess there is no problem. Okay, it will be all right according in meantime, I guess. So let's wait. So okay, so basically, out of this number of possible decision functions to divide two classes into different planes, support vector machine mean to find one optimal plane. Okay, so it's actually working with the principle of maximal margin, where it actually wants to find a margin which will separate between these things, which will be the maximum and optimal hyperplane or margin. So basically, this is the margin. So we can actually take this decision function or this decision function. But the maximal margin means ki out of this type of different, which will be the optimal one. So this will get better solution rather than this. So this is what how support document works. Okay. We need to find maximize this 2 by 13 2 by W with respect to these two classes. Okay. So this will the optimal this the decision function can be found solving this optimization problem. Okay. So this is how SVM is working. This is the working of SVM. So now for multi-class, two type of multi-class SVM. One is one versus one approach, which actually take pairwise classes and find decision function like this. And one is one versus all approach, where we take one class versus the rest of the classes to find a decision function. Okay, so basically multi-class SVM convert the convert the multi-class SVM convert the multi-classes to binary classes, then do the classification task. Okay. Similarly, for regression problem, what we mean, instead of classes, we restriction to the y, we don't have restriction to y, we have a real number, which represent the desired response. Okay, so on here, the regression problem, we actually intend to find a function g of x, which actually better approximate the value y. For regression problem, we have an extension of SBET, where instead of classification, do the regression task. Okay, that is what we call subvector regression. Out of this, we have other variants of SVM like E square subvector machine, proximal subvector machine, which are the improved variants of SVM, uh, which act better on classification and regression problems. So then we have different soft computing techniques that we can use. Out of those, digital algorithm is the most popular one, I guess. So a genetic algorithm actually uses the biological terms like inheritance, mutation, selection for its working principle. Okay, the main idea will be Darwin's fundamental principle, that is survival of the fittest. That which principle is used to find the selection of the better solutions. Okay, so this is what the process look like. Total process of simple genetic algorithm, where we first initialize our population or the sample solution set, then we evaluate our function. I hope optimal technique means we have talking about techniques, mathematical techniques here, which to solve optimization problem. Okay, so genetic algorithm actually first initialize all type of solution, then evaluate the objective function, then we do our terminate criteria. If it's met, then we found our desired solution. If not met, then we do our selection, then crossover, then mutation, and accordingly we evaluate our objective function and do this loop again and again to find an optimal solution. Similarly, principle of how an ant colony finds the shortest path from its place of stay to the food. Okay, it's a cooperative or collective work do by all ants as a possible number of paths or solutions. They go about all paths, traverse to all paths, and finally found the shortest path. Okay. So this is what a general basic SEO work. This is what, like first we initialize our SEO parameters, then we found the probability distribution or pheromone trail to find the how the solution that is important to the other in comparison with the other solutions. Okay, so basically SEO is working on this principle, the simple principle of how R and R colony find a shortest path. So these are the two algorithms that has been used. Uh, Other algorithms are there also, like ABC, PSO, short intelligence algorithm, and harmonic search algorithms also. They are all short techniques for optimization problem, heuristic optimization techniques. So okay, now and general predictive learning structure has three main modules. Okay, first is a pre-processing part, which include data collection, our input feature set generation, then training set, testing set generation. Then our model training, where we train our machine learning or neural network models like weight and cross validation and hyperparameter selection. Okay. Then our model testing part, where we actually do our prediction or classification and further the performance evaluation things. Okay. So basically, in a general learning problem where we want to develop one model for this specific task, we actually want to work on three models, like in pre-processing model or feature engineering, basically, where we want to find an optimal feature set that can be used to give us a better forecasting results. And in model training, we intend to find the optimal weights or hyperparameters which can be suitable to give better results. And in model testing, which is the main part where we actually get our results. Okay, so basically in input features we have x1, x2, x1 input features and our target variable y. And what we do, we actually find and we actually tell is this x1 expression actually contributing to find our expected variable y. Okay, so sometimes what happens is some variables is less relevant and some very relevant. So this less relevant variables if you can discard, then the results is actually improving. So that is what feature selection means. Like instead of using all features, we take relevant features and we discard less relevant features from the whole set of input features. Okay, so that can be done by using different type of techniques. Like you can just calculate the correlation of these things with y and decide which are less relevant to y. And simple statistical technique. Other techniques like we can take random forest, we can take relief algorithm. There are different type of techniques that have been used by researchers for this purpose. So here we have taken we are talking about importance score. Importance score means like in this column vectors x1 x2 that what input sets are. We decide the importance of the x1 x2 with respect to this target variable y, and then then we decide which are less important in terms of y. So, so that is what we call recursive feature elimination strategy. Okay, so here there are two type of techniques that I'm going to discuss. One is relief wave, that is regression relief wave, or one is random forest. There are two techniques. One is filter type selection technique, which um, dependency distance of the variable x with respect to the output state y, and on a random forest, which is a machine learning technique or embedded type feature selection, where we actually train with a random small number of set to find input contours of the input features. Okay. So basically, the recursive feature elimination strategy, what it actually eliminate less important feature according to their importance scores. That means we first decide our importance scores according to our feature selection strategy. Then we sort this and we discard which way in. So basically, an RFP based training, what we do, we first feature ranking using, like suppose we are using random forest. So using random forest importance scores, then we just sort these things, keep n features from n equal to 1 to total n feature, then we eliminate one by one. Okay. To find an optimal feature set that actually uses uh, for the learning process. Okay. So now the last what the title is showing, like ensemble of both techniques, machine learning and subcomputing. So here, what is ensemble learning? Sometimes there are different type of machine learning algorithms like this, like decision trees, random forest, super vector machines, means variants of super vector machines also, and there are artificial neural networks, deep learning, etc. So out of this, ensemble methods what do, it actually combine, instead of rely upon one single technique, it actually combine different type of techniques for the same task. Okay. So how? Because what we can see during the implementation of different techniques, like according to data, sometimes the different techniques giving different results, good results. So it's actually difficult to rely upon one standalone machine learning technique for all the data types. Okay. So to overcome this weakness of single technique, to rely upon single technique, we actually take all techniques and ensemble those techniques according to some weights. Okay. Collective average of multiple experts beats the accuracy of any one average. If you take one averager, then it may be biased for the data set only. Okay? But if you take collective average of multiple experts, this is the basic principle of how ensemble learning works. Right? So what is assumed is, suppose we have done data and we have base learners, like suppose it's SPM, it's random forest, is some LSSPM, some PSBM, some ANN. So it actually train this model using the data. Then it combine those predictions and take it to a meta learner, that is our ensemble learner, that can be autonomy optimization to find the weights of the base learners, or genetic algorithm, or particle sum, or simply averaging of these things one by n. So this is what ensemble learner or meta learner that we have done. Then now we do a final prediction, and this is what a complete ensemble learning structure looks like. Okay. And simple thing, like we take the base learners, do the prediction, then take it to the feedback for the ensemble learner. That is actually some strategy that we are defining, user defined. Like you can just take the, suppose classification, then we take the maximum votes, mode of the uh, mode of the uh, all prediction that we get. We take the mode. It is the maximum vote get the class that will be our ensemble prediction. That is a simple ensemble technique of classification and widely used. Or we can weighted sum of these base learners to find the final prediction. Okay. Now our third part, that is the financial price forecasting problem. So nowadays we know how this uh, due to this growing industry of finance, where we actually want to invest in portfolios, in mutual fund, in bond, in ETF, these are stock, or now these things that we are getting cryptocurrency also. So here the investing problem take us to the industry. If we know the how the price is acting in future, then we can actually take our investment decisions or trading decisions. Investment means like if you can longer term, if you invest the money longer term, that we what we generally call investment. And in trading, trading means we actually do it for short term to gain money quickly. Okay. So trading means buy versus sell, or investments you want to buy and keep the stock for longer term to achieve another goal. So here the research objective of this talk that I am telling is ensemble of both machine learning methods with subcomputing techniques for vector predictive data analysis applications. And out of those applications, finance forecasting is one of the important applications. Okay, so here basically I am taking one of the financial instrument, that is stock market index. The index means like Nifty 50, NSE, BSE that we are talking about, the Dow Jones in USA, or SP 500 in USA. So index actually um, consists of specific stocks of that whole stock exchange. Like in NSE, we have whole Indian companies are registered with NSE, and out of this, if you take 50-50, it is actually top 50 large cap companies which contribute with some weights according to their market cap to find an index Nifty 50. And Nifty Bank actually consists of different type of um, of the bank sector sectoral index, where different sector index we trade from a different bank stocks of bank of stocks. Okay, so. Uh, so if we can predict the index price, then we can actually find an overall view of how the that specific sector is going to work. Okay, so that is actually represent all the stocks coming under that specific index, like Nifty 50, Nifty Bank, Dow Jones. Okay, so so basically the stock market index future price prediction actually in financial time series problem. You can take it as a time series problem because it comes with a timestamp. Okay. So in today's in our day-to-day life, the stock price forecasting is a demanding task, because of if we know the future price of stock, we can actually take our investment decisions. Okay, or uh, we can trade our trading decisions like buy, sell, or just to wait. Okay. And to how we can take, we future price. So here, what we have done, we actually some hybrid multi-category models using ongoing optimization, symbol of different types of hybrid models on to find a better prediction. Okay. So how the motivation comes, like the how this research comes, the motivation is what I find first. A number of statistical models have been used for price forecasting problems, and we can find this in this paper. And similarly, machine learning techniques have been used efficiently for financial time series forecasting problems. And out of those machine learning, software machine found an possible alternative because it's faster, so sometimes faster, and actually it's static and high generation capability, and it has a well mathematical formulation behind that. And also, as we know in this model, we have deep neural networks which actually um, give a boost to using DNNs in financial time series forecasting. Okay. So these are some of the references where these evidences have been come that I am telling. So what for ensemble learning, what motivates me? Like in traditional methods, we have limitations of non-linear hyperprecision in financial finance data. Okay, actually the finance data is uncertain, like chaotic in nature. Like you don't know actually what are going to happen in the next moment in a stock market. Like we can see recently the stock market is going down, down, down. Then it's suddenly going up, then down. So we don't know what is going to happen. It's high fluctuation due to other factors like economic factors, like some news comes from um, government or some sentiments like the market is going to crash or the company is not performing well. So that actually affecting the market. So you can just tell like we can tell seeing the weather if it's going to rain or not. That is one periodic pattern. But here we don't see any periodic pattern. It's actually in high fluctuation and noisy. So that motivates just not using traditional methods. We use some hybrid methods where we incorporate heuristic optimization like uncolony optimization, like genetic algorithm, like particle sum optimization. Here I am using SBM. People are using deep neural network and others to find a better price forecast. Similarly, our the traditional approach are based on the assumption that we assume that like we just take the all features and give it to the machine learning algorithm, and the assumption is everyone is contributing equally. But that's not true. Sometimes there is some less relevant features that is going to be added. So we just need to discard it using feature engineering. So that what hybrid learning algorithms can do. So what the performance can be improved by if we can assign different weights in according to their importance score. It is one of the part. Instead of you just discarding those things, we can also um, do the feature weighted instead of feature selection. Okay. This is the earlier I have talked about feature selection, and here I am taking about feature weighted. Instead of just give them less features, less weights. Okay. This motivation tells about using feature engineering techniques to for hybrid learning algorithm instead of just use any machine learning algorithm. Okay. Then suppose what we find that I have told you earlier, uh, individual standalone model can be can be used for every stocks. Like others different for different stocks, different algorithms are performing better. So we can just rely upon one individual algorithm for all stocks out of those learning algorithms. So recent works what we have chosen, we focused on performing hybrid ensemble models for accuracy forecasting. So what ensemble models do, that what I have told earlier, like it actually combine different individual models to do the prediction instead of using one single model. Okay. There is some important differences which are the evidence that what I am saying. Then school models make use of the merits of all individual prediction to produce one improved ensemble result. What it takes, it actually considers each individual model as an independent contributor and integrate the responses intelligently. Intelligently means like you can just take the either the stuff that one of the intelligent things, or you just want to more intelligent tech, you use heuristic optimization techniques like colony, genetic algorithm, particle sum optimization to decide and weigh for the each individual contributor or the individual models. So now that's what I'm saying. Suppose this is a Nifty 50 index data. So as we can see, these data are highly um, chaotic. So, but the trends, what is trends in market? Like we have this flat trend means the market is not fluctuating that much, or we have a downtrend where the market is going down and the uptrend. In every stock market, there exists three trends only. One is flat trend, one is downtrend, and one is uptrend. Okay, so this if we can predict these trends, we can actually take the trading decisions. Like if we know that the company is going down, then we can actually sell. Or if it's going up, we can actually buy. And if it's flat, we can wait. Okay, wait means we can wait to change of the trend. Then we can take our trading decision. That's what we will do in general. So in a mm, in here to predict this trend or to predict the price, we actually what we can take our input features. Input features we actually take technical indicators. Technical indicators means the indicate that has been defined. Like we can take open, low price. Those are actually uh, related to the closing price or the price. Like we have moving averages. We actually follow the trend. Okay. Once you have go through the any stock market, like there are different type of mm, platforms exist where you can actually see these how these technical indicators are. Just go to simply trading view and put these technical indicators one by one, and you can observe how these technical indicators actually follow with the price trend. Okay. Now, what will be the output level? Basically, this slide actually telling about what can we take as our input features and what we can take as our output level, or what will the output and what will the input. Input exceeds the technical indicators along with the price data. With the time series, we take the historical data as our input, and with the historical data, we actually take these technical indicators also as our input set. And output level Y will be up, down, or flat. Accordingly, we can actually, instead of up, down, flat, we can actually trade our trading signals, buy, sell, or wait. Okay. So, in price data, we take the price data or historical price. This is actually how and machine learning, any machine learning technique we can use for the trend forecasting problem. Okay, so we take the historical price data, we find our technical indicators, other input set, then we have our model, we get this. Well, this means in any historical price data, you find in finance, you find on open price, on low and high, and on closing price. That is our OLSC price. Okay, and technical indicators are input, and sometimes we need market sentiments like political news, company sentiments, or public poll. What public is saying, the company is going down or up. Okay, those techniques are the input. These are external factors. These are input to our basic SDM model or machine learning model, then our output trend. It's a basic structure how a trend forecasting using SDM works. Okay, so basically here the Ensemble technique that I am talking about, how this works. We first do the data collection, then we we create our input state using technical indicators. Then we divide it to training set, our correlation set, and output set. Then we take our input and score generations. Here we have random forest input in one of the technique, and one is this is chi-square test, and one is relief test. Okay. And now this gives us our new input features. This part is actually our feature engineering. Okay. This is feature engineering. Then one model training part where I have taken two models here. So the experimental models. One is list super SDM, one is functional SDM. Those are two modified versions of support vector machine, and which give us total combining with different type of important score based feature, that what we have feature different feature sets, we actually find different type of hybrid learning models. Okay, and these models, then in these models actually predict the testing set, using this testing set the individual trends. Then those individual trends, the value then optimized by SEO, where it's optimized by SEO, and do the ensemble prediction. Then we do a evaluation, performance evaluation, like accuracy, or can take the rate of return, etc. So basically, this works as a three-stage strategy. First stage is the important code generation and training. Second stage is the hybrid models and individual trend forecasting. And finally, our stage three, where we actually do our ensemble prediction and then evaluation means performance evaluation. Okay, so according to using these techniques, these are the results that I'm getting for different uh, indexes like Dow Jones, Nasdaq, Nifty 50. Here I am presenting eight different indexes, and two different out of them. Accordingly, four different input feature generation strategy. So total 4 plus 4, 8 plus 2, 10, 11. Total 11 and 1 Ensemble. Total 11 strategy. The results are showing Ensemble results are performing better than the individual models. That's what I was saying earlier. Like Ensemble result take the these individual results as the independent contributor are find them better performing results. So for all indexes, it's performing better. So now what happened? Here what we have done, we actually read the trend. Okay. Here, here we actually what we are doing, we are actually predicting the trend of down or flat. Accordingly, for up, if it's going up, it's going up, then we will buy, and if going down, we will sell. Else we wait. So we have we get our three trends. If we take the now, it's just so our work will not be done here. We need to use those things to actually making money, because that's what we are interested. So for this, we actually this is a simple trading system, that how we can actually long means we are taking investment, and sorry, we are actually buying means long. Short means you are actually selling first then buying. Okay, there are two type of market scenario. One is long, where we actually first buy, then sell, and in stock market you can actually do the opposite also. Like you can actually, if you know that the price is going down or in future, then you can actually short or actually sell first, then buy later. Okay. So if the signal is buy, then what we will do? We will buy at open price. Okay, and tell that our position is long. Okay. Okay. Then if the signal is there, then what we do? We just sell the sell first. Okay. And if it's signal is wait, then we just wait. We don't do anything. It's a simple structure how one simple trading system is working. Okay. It's simple. It's buy, you just buy, you just sell, and accordingly, if it's intraday, like you are trading in intraday means you want to means you want to trade daily. Like in morning, you want to buy or sell, then at the end of the day, you want to square up everything and wait for the next day. Then the square of the short position at buy and square of the long position at sell. Okay. So this is a simple trading. So here using this algorithms for different these are the results. These are the trading signals that we are getting. I hope it's visible. Like these are the trading signals, like where we are getting buy and here getting sell. And this graph is actually generated to the trading signals that we are getting from the machine learning models. Okay, this is actually trading signals that we are getting from the ensemble model. This is an sample results from 5050 and this is from thousands. I have taken two different type of graphs to show you that how these machine learning models are working in two different models. Okay, so then this is one of the part. And second part is suppose we are interested in price only. Like what will the price in future? How the price will going to work in future? Like uh, in multi-day, what will be the price trend? Instead of using see up down and weight, we actually interested in the price. Like what will the price at the specific day? So that actually tells us about how the market is going to fluctuate, and we can do like instead of investing, we actually interested um, in in future trading or option trading. Those are the two things or derivatives where we actually interested in the price. If we know how the price going to act, we can actually take the trading decision of the future trades. Okay. So here, uh, this is one of the techniques which we um, call direct forecasting, where at time t, at the t day t, we assume that the t from t plus 1 day to t plus h day, every day is dependent only on this price trend. Okay, then we actually train different independent models for different day forecasting. Okay, means input set is same, but we take for t plus one we have one model. We train different machine learning models and do the forecasting. This is the complete structure where we are using different type of support regression variants. The similar thing, we take the historical data, do the input features, then we input take different type of importance code generation strategy. Okay, accordingly we found our new input feature sets, and with this new input features, different new input feature sets with different algorithms. Here, like we have four different input feature sets and three algorithms, 4 into 3, 12 hybrid models we are getting with three baseline algorithms, LSSB, SLT, and then we train our model in our stage 2 and do the individual forecasting, then use those individual forecasting to feed to the endpoint optimization model and do the install forecasting. Then we evaluate our performance simulation. Okay. I hope it's clear. Like it's a three-stage strategy that uh, has been proposed. So here the results. Okay, it's result from browsers. Okay, so here we can see that norm square error tells us about that ensemble technique is performing better than all of our techniques, all of the techniques. Okay. So this is the price forecasting results for 1 day. That is blue color line, and 3 day that is green color line, and red color line is the 5 day forecasting. Obviously, the this downtrend is because of that COVID pandemic scenario. It's the data has been taken during the last February. This is February, March 2020, April 2020, March April 2020 day. So here the we can see though the market is very fluctuating that time, still the Ensemble model is able to follow the trend. Okay. This Nifty 50 data here also Ensemble technique is performing far better than baseline algorithms, and this is the results. Uh, as you can see, this is our panic scenario. Like we have all type of market scenario. This is flat, this is down, and this is up. And the results are showing how this price trend of the multi-day price trend is actually following. So we can take our decisions. So this is the Hang Seng stock index. Okay. So now apart from uh, finance instrument of stock, we can actually take about different financial instruments. Like this is a forex, foreign exchange, and the results are showing how instead of using baseline variance, the hybrid variance working better. This is accuracy, classification accuracy for like trend forecasting for forex market. We have taken 5 for the experiment, and this is cryptocurrency market recently popularly popularized. Like these are the 5 different um, cryptocurrency market, and cryptocurrency market is basically high fluctuated, so the algorithms are still performing better. And this is our commodity market. We have taken 5 different commodities to show that the hybrid algorithms are performing better than the uh, best algorithms. Okay. Now, what microscopes that we can see, like we can incorporate new clinical indicators during our research engineering. Then we can actually experiment over different research engineering approaches. Okay, and obviously we can incorporate deep learning, deep neural network techniques. We can actually this to real-time trading systems to actually make in real-time money. Okay, and also during thing, keep in mind to find an control trading strategy like put strict stop losses and buy and sell high frequency tradings to uh, escape from the unwanted losses. These one type, some type of feature scopes that actually used to make money. So these are the some of the more references apart from those references that I have been told in my slides. Thank you. If you have any questions, we can take now. Sorry, it's audible. It's audible. Thank you. Yes. Thank you. No? Sorry. Yeah, actually, I want to inspire everyone to take financial personal finance as a thing like personal wealth management during this investment and all. And believe me, USA, we have out of almost more than 50% of USA population is doing investment and making money. In India, it's actually 4 to 5% or 10%, you can say. So you can actually give algo trades and boost up. To be actually to investment instead of doing an only FD, you can actually invest in stocks or in mutual fund actually to make money. Just 3 seconds. Thank you.